Hi everyone. It seems like it's been a long time since we've had a video, so I'm really excited. We're starting chapter 3, and if you look at the notes that I gave out in class today, you may notice that it says 3.5 on the top, 3.5 notes. So just go ahead and put the date on your paper. And in class today, I did do a very quick review of sections 3.1 to 3.4. Those are pre-algebra topics, and you guys showed me in class that you actually felt pretty comfortable with them. So I'm going to actually start just by reviewing what came up in 3.1 to 3.4. I gave you a question, an equation like 3x minus 7 equals 11. So it's on the warm-up of your notes. And we talked about how the question would ask you to solve for x. And anytime you're being asked to solve for x, what I'd love to see you do would be to think about this as backwards PEMDAS. Backwards PEMDAS. Please excuse my dear Aunt Sally. Because when you solve one of these equations, that's exactly what you have to do. You have to work backwards, in reverse. I also want you to think about it we're going to be using a technique called balance the equation. Okay? Because whatever you do to one side of an equation that has a variable in it, you have to do it to the other side. So in this equation, 3x minus 7 equals 11, we're going to solve by adding 7 to both sides. So we're going to do the addition and the subtraction from the PEMDAS first. So I add 7, negative 7 plus 7 will make this cancel. So I'll be left with 3x on the left. 11 plus 7 will give me 18. And then to solve for x, we would divide both sides by 3. We're trying to isolate x. We're trying to get x by itself because the question would say solve for x. The 3's will cancel, and then you would simplify your answer. So 18, remember that division bar just means divide by 3 would give me x equals 6. And then, of course, we don't want to forget to box our answers, okay? So that's a review of what we did in 3.1 to 3.4. Well, 3.5 takes it a little bit further when it puts variables on both sides of the equations. And these questions are going to get progressively harder. So first, we want to get x on one side and the number on the other side. So the rule I always use is I want to bring the smaller x to the larger x. So in this example, a negative 3x is smaller than negative 2x. So I'm going to bring it to the other side. Since it's a negative, I have to do it the opposite operation because it's backwards. So I'm going to add 3x on both sides. And I do it right under, so it looks nice. And then I'm going to simplify. So 2x plus 3x gives me 5x. I have minus 2 equals 3. So now it looks like the equation we just solved. So we're going to balance the equation by doing backwards PEMDAS. We're going to get x by itself. We're going to add 2 to both sides. So we get 5x equals 3 plus 2 is 5. Then we want to get x by itself, so we're going to divide both sides by 5. And we get 5 divided by 5, which I'm hoping you say is 1. Okay? All right, let's keep going. How do these get harder? These get harder because I'll just add more variables to each side of the equation. The first thing that you'd want to do is on each side, you want to combine like terms. So I've got this 6m and 7m. I'm going to combine them. So 6m minus 7m is going to give me negative m plus 5 equals 10m plus 3. Again, we're going to bring the smaller variable to the larger variable. So negative 1m is smaller than 10m. So I'm going to add m. I'm going to do the opposite operation. I will be left with 5 equals 11m plus 3. Again, I want to get m by itself. It doesn't matter which variable I use. So I'm going to subtract 3 from both sides. We are left with 2 equals 11m. Again, we're trying to get m by itself, so we're going to divide both sides by 11. Do the division, because this will cancel out the 11, so m will be alone, and my answer would be 2 over 11. And I think I even gave you a little place to put it, so m equals 2 over 11, and we're going to box our answer. Doing okay? Okay, good. And some of you might think that this is a review as well, but I'm going through each step just so that we don't make any mistakes and we can practice. All right, so again, I see variables, I see longer equations. First, we want to combine like terms. And if you feel comfortable with this, try it and press pause and then see my solution as you're going. Remember, you can always do that. All right, so we have 3n minus 15 equals 5n minus 4n gives me n plus 3. All right, we want to bring the smaller variable to the larger variable, so I'm going to bring the n over to this side. Rewrite my equation, so 2n minus 15 equals 3. Now, I'm okay with you guys sometimes, if you want to, going ahead and doing more than one step in each. I'm going through each step so you see the work that's being done, okay? So I'm going to add 15 to both sides, and 2n equals 3 plus 15 will give me 18. Then I have to still backwards PEMDAS. So if I'm multiplying, I need to do its opposite, so I'm going to divide both sides by 2. So n equals 18 divided by 2, but we're always going to simplify our fractions. So 18 divided by 2 equals 9. And again, box our answer. Okay. Now they're getting slightly harder. How are they getting slightly harder? Because I'm throwing more negatives and positives in. So on question number 4, it's similar to the one that we just did. So I'd like you to save this question for tomorrow. That's going to be one of our review questions. All right, let's go on to number 5. How did I make number 5 harder? I made number 5 harder by throwing in parentheses. The first thing that you need to do when you see the parentheses is you actually need to simplify the equation. You can't do backwards PEMDAS and solve until those parentheses are gone. So we're going to use the distributive property. We're going to make sure we use our arrows, and we're going to distribute the 3 through. So 3n minus 6 only goes through the parentheses, and I still have to subtract my 1. On the other side, I have 2. I have a negative 5 that's going to get distributed to everything within the parentheses, so I'm going to be left with minus 5n minus 25. So don't forget that there's a negative here, so you have to multiply it by both the 5s. Now we're going to combine all the like terms. In this case, I have like terms that are just numbers, so I'm going to combine those, and I'm going to be left with 3n minus 7 equals negative 5n minus 23. And it wouldn't matter. If you put negative 23 minus 5n, that would mean the same thing. All right, so we're going to bring the smaller variable to the larger. We're going to add 5n on both sides. Okay, and so right now we have 8n minus 7 equals negative 23. Now I want to isolate n, so I want it all by itself. So I'm going to do backwards PEMDAS. I'm going to add 7 to the other side so that n is getting closer to being alone. And so we have 8n equals. Okay, so I threw in these negatives now, so we got to remember those integer rules. We have a negative 23 plus 7. Different signs, subtract the number's absolute value, and then keep the sign of the larger. So I'm just going to do 23 minus 7, which is 16. The larger term, so 23, is negative, so I have to keep my negative. All right, so I'm getting closer. I'm going to divide by 8 on both sides. I'm going to undo the multiplication by doing its opposite. So the 8s will cancel, and I'd be left with negative 16 divided by 8. So be careful, because we need to remember that when we divide a negative by a positive, we will end up with a negative. So n equals negative 2. And I circled my answer here, so I'd like you to circle your answer instead of box it. That way I know that you've been watching my videos. Okay, let's keep going. Doing great, guys. So question number 7. Question number 6. So 3 times 7 plus 2x equals 30 plus 7x minus 1. All right, so we have to distribute first and simplify the problem before we can get x by itself, before we can do backwards PEMDAS. So we're going to multiply. So we're going to distribute our 3. Distribute just means multiply. We're going to distribute our 7. Remember, distribute just means multiply. So we're going to get 3 times 7, so 21. 3 times 2x, so plus 6x, equals 30 plus 7x minus 7. Okay, so then we want to get x alone. We're going to bring the smaller x to the larger x. So subtract 6x on both sides. All right, so now we have 21 equals. We're going to combine the like terms here. So 30 minus 7 gives me 23 equals, 23 plus x. Okay, so 23 plus x. All right, getting closer, I'm going to subtract 23 because I want to get x alone. So this is addition right here, so I need to do its opposite operation, backwards PEMDAS. Then I have 21 minus 23. Different signs, so subtract the numbers and keep the sign of the larger. So 23 minus 21 is 2. The larger term is negative, so minus 2 equals x. And then again, box your answer. Okay, so right now, you guys should hopefully feeling more comfortable with this. If anything we've done so far, just remember to ask the question in class tomorrow, okay? All right, and let's just star answer because we're doing so well, okay? All right, 4 times 3 plus 5y. So number 7, I'd like you to save it. That's going to be my review problem for class tomorrow. And we're going to go to the last and the hardest problem. Why is this the hardest problem? Yes, because there are fractions. So those of you that don't like your fractions, the fractions should tell me I need to stop. I need to slow down. This is my stop sign. Okay, so we still have to follow the same rules we just did. We are going to distribute our 1/2, simplify the problem first. So those parentheses cannot be there for me to solve for x. And I'm going to distribute the 2/3. Now remember, distribute means multiply. So I have 1/2 times 2x. So I'm going to do that over here for you so you see it. And remember, simplify then multiply. 2 goes into 2 each one time, so you're left with x. 1/2 times 6, again, I'm going to do it over here, times 6 over 1. Simplify then multiply. 2 goes into itself once, 2 goes into 6 3 times, so plus 3. Now I want you guys to try this side, and I'm going to tell you what you end up with. So I'm giving you a second to write. Okay, so the way I did it was, I distributed 2/3 times 6. 3 goes into 6 2 times. So 2 times 2 is 4x. Did we get 4x? Yay? No? It's okay if you didn't. We'll practice tomorrow. So 2/3 times negative 12. So I know my answer is going to be negative. 3 goes into 12 4 times. 4 times 2 would give me 8. Then I simplify. I bring my smaller variable to my larger. So I'm going to subtract x to both sides. I have 3 equals 3x minus 8. All right, remember I'm trying to isolate x, so I'm going to bring the 8 to the other side. And I'm going to add 3 times 3 plus 8 is 11. 11 equals 3x. Then what? Divide by 3 on both sides. So x equals 11/3. But Coach Fred doesn't leave it like that, does she? So I'd like you to go ahead and change that into a mixed number for me. And I'd like you to box your answer. And I'm going to be looking for that tomorrow, so I want to make sure that you did that correctly, okay? So hopefully this wasn't too long for you today, and see you tomorrow in class. Bye-bye.